There are calls for an investigation after a power outage put the lives of patients at risk at White Memorial Hospital in Boyle Heights. Emergency crews had to evacuate hundreds of patients, some in critical condition, and rush them to other medical centers.
Backup generators that were meant to last for 3 days also.
The past decade for Africa's biggest economy has not been so bright. The country has gone through a period of blackouts, suffering a huge electricity crisis.
Hello, we are Team Voltage. Our problem statement ID is SIH 25116. Problem statement title is Smart Microgrid Management and Energy Storage for Reliable Renewable Energy. The theme is under renewable energy. So let's start with the presentation. In today's world, electricity is not just about comfort. It is about survival, growth, and opportunities. Villages, hospitals, and campuses often depend upon solar power, but face serious problems when the sun goes down or when clouds suddenly block the sunlight. Batteries alone are not always reliable. They degrade faster or fail under sudden load spikes. They also cannot meet the night peak demands. This results in blackout, and hence the dependency on diesel generators increases. Our idea addresses pressing the challenges by designing a smart microgrid system that uses AI forecasting, hybrid energy storage, and real-time monitoring to ensure stable, cost-effective, and sustainable electricity. The problems that we are going to address are: first, sudden solar drops; second, nighttime peak demand; third, battery stress and degradation; fourth, dependency on diesel generators; fifth, lack of monitoring and control. To address this, we are building STABIGrid, a smart hybrid storage system designed for stability and efficiency. So let's move on to the solution, like how we are going to solve it. First, AI/ML based solar forecasting. It is going to predict the solar output and weather patterns. Second is the hybrid storage, that is battery plus supercapacitor. Battery is used for the storage of loads and supercapacitor is used to handle sudden spikes. Third, smart load balancing controller. Now we are going to use this controller for auto switching between solar, battery and grid depending upon the situation that arises. Fourth is supercapacitor integration. Now the supercapacitor is used to divert load spike and extend the battery life by ensuring that no sudden load is harming the battery. Next is intelligent charge scheduling. It is going to use the surplus of solar energy for efficient use at night. Next is scalable AI controlled microgrid. It reduces the dependency on diesel and hence with predictive balancing. Next is interactive web dashboard, live tracking and management of solar, battery loads and grid.
Okay. Here we have the technical approach and flowchart of our system called STABIGrid. Starting from the left, solar panels generate DC power which is managed by MPPT controllers. The energy is then directed towards the battery and supercapacitors, which helps reduce stress on battery during sudden load changes. The inverter is used to supply power to both critical and flexible loads as well as interact with the grid. All these power flows are monitored by sensors and the data is processed through a microcontroller. The microcontroller not only controls the power flow but also sends the data to the edge gateway. From edge gateway, data communication is established with our mobile app and web dashboard. Here, users can monitor the system performance and control operations. On the backend, we have combinations of Fast API and Node.js, while the front end we use React.js and Chart.js along with Tailwind CSS to build an interactive dashboard. For databases, we have integrated InfluxDB, MongoDB, and PostgreSQL, ensuring both real-time data handling and reliable storage. Overall, the flow ensures stable, efficient, and intelligent energy management with smooth communication between the hardware and software.
Hello. So now moving further towards the feasibility and viability of our project. First of all, our feasibility and viability. So first of all, the category will be market demand and user base. How it will be feasible, that is high need in villages, campuses, hospitals for reliable and renewable power. How it will be viable, that is ensure continuous power, improve trust in solar adoption and scalable across India. How it will be technologically feasible. Our project is so feasible technologically as we have used proven hardware only, that is solar battery, supercapacitors, ESP32, that is a microcontroller, AI and IoT for stack for predictive switching. Scalable with cloud APIs, modular design for larger grids. Financial and resource feasibility. Low cost prototype with off the shelf components, scalable manufacturing. Our project is a long term saving by extending the battery life and reducing the diesel grid reliance. Our project also provide a few content and services, that is dashboard for real time monitoring and control, and it will also provide an user empowerment, transparency, control and smarter energy users. Also, we will be organizational collaborations. Our project will collaborate with and partnership with hospitals, NGOs, villages for pilot projects. We can also support smart villages programs, campus sustainability drives and government schemes. For our legal and regulatory feasibility, we will be compiling with the MNRE India microgrid standards and safety guidelines. It will be also viable that we will ensure easier integration with government renewable policies and subsidies. How it will be community engagement and growth. For community and how it will be feasible, we will be reducing the blackout support. We will support also healthcare loads and lower carbon emissions. Our project will also contributing towards the SDGs. SDGs are those which our current industries need. So how our project will align with SDGs? First of all, our project will align with SDG number 7, that is affordable and clean energy. Our project will be promoting the sustainable grid, hence our project aligns with SDG number 7. Our project also aligns with SDG number 9, that is industry, innovation and infrastructure. Our project will be working for small scale industries which are paying too much bill than their actual demand or other reasons. Hence our project will be an also improvement for the small scale industries, that we will also align with SDG number 9, that is industry, innovation and infrastructure. Moving further, our SDG also align with SDG number 11, that is sustainable communities and cities. Our project will reduce blackouts and support healthcare loads. Hence, we will be promoting the SDG number 11, that is we will be promoting communities to use this project and contribute towards the sustainable development goals. Our project will also align with SDG number 12. Our project will reduce that is responsible consumption and production. Our project will ensure that everyone uses the solar, hence we will be promoting the sustainability. Our project will also align with SDG number 13, that is climate action. How we will align with climate action? So we will reduce the use of diesel generators, that will actually be beneficial for our climate. Moving further towards the impacts and the benefits of our project, team voltage brings our project SIH. How it will be beneficial? We will extend the battery life. It will also provide an uninterrupted power supply. It will be efficient energy utilization. We will lower the dependency on diesel grid as already mentioned. User control through dashboard. It will be shown further in the next slides. How it will be impactful? The major impact will be the hospitals where there are severe cases which have been. It will prevent ICU and vaccine storage failures which are actually got due to the battery energy storage system. We will also eliminate nighttime blackouts in the villages, that is sustainable cities and communities. Further, it will protect appliances from voltage fluctuations, as we already mentioned. We will be using supercapacitors. Further, it will reduce the diesel generator uses, that is once again the point of sustainability. We will build the trust in solar microgrids. We will be promoting solar microgrids, and this is how our project will stand different from everyone else. Thank you, and moving further, I hand over to Pranav.
Now talking about the research and references, according to research that we've done, the career advancements of the project includes it can reduce the electricity bill by switching the supply with respect to ToD tariffs, that is when the incentive time zone is there of the tariff. We can pre-charge the batteries and shift the load to the grid, along with shifting load to the batteries when the ToD tariff time zones are such that they are charging money from us. Talking about the maintenance cost, the product significantly reduces the maintenance cost of batteries by AI switching and smart switching of the batteries to grid, along with the help of prediction and forecasting. Talking about the dependency, project implementation will lead to up to 30% improvement in solar dependency in rural areas and build trust in renewable energy in the rural areas. These are the references that we've took. First is the Ministry of New and Renewable Energy (MNRE) Government of India's website, where the year-end review of 2024 was very helpful for us to find out the problems that are occurring in India in this sector. And then others are some research paper that we've gone through to get brief idea about the solution. Now let's take a look at the homepage of STEBIGrid website. Here we can see the solar output that's produced by the solar panels and the battery status, how much battery is remaining, and on the current load how many hours the battery will sustain. The grid connection stability is also mentioned here. Active loads are also mentioned. We can also control the switching of battery to grid in with respect to percentage, like 50%, 60%. We can increase it or decrease it on the website. We can also enable or disable the eco mode, critical loads mode, and emergency mode from the website. This is the user alert system of STEBIGrid. Here the users get alerts and AI forecast about the weather, the battery health, the efficiency updates that are updated to the users through their emails and messages. These are the AI predictions according to which we can set the battery and grid percentage and switch them manually. This is the user-friendly data reports and analysis of STEBIGrid. Here we can see the reports include daily energy split, that is how much we've been dependent on the renewable energy, that's solar energy, and how much we've been dependent on the battery, and how much amount of energy we have taken from the grid. So accordingly we can monitor our expenses of the energy. The grid dependency trend, that the weekly grid dependency trend we can see here. The usage of grid power throughout the week, if it's increasing or decreasing, we can monitor through this trend. And we can also calculate the cost saving through the website, where we can monitor the grid power usage and monitor the cost we've been able to save by using the solar and batteries.